2.6 linear inequalities in two variables. Your goal is to learn how to sketch the graphs of linear inequalities. The essential question you just need to think about while you're watching the video and doing your homework. Homework is problems 6 through 14 in the homework packet. Some vocabulary. AX plus BY greater than C is called a linear inequality in two variables. A half plane is one of the two regions formed by a line graphed in the coordinate plane, and it'll become more apparent when you watch the examples of what a half plane is. Example, we're going to graph this linear inequality 2x minus 3y greater than 6. Step 1, graph the line. So they get rid of the inequality and they just want you to graph the line 2x minus 3y equals 6. Then you're going to determine what type of line you need. Is it a solid line or a dashed line? To do that, if you have a less than or greater than, you're going to use a dashed line. And what a dashed line means is that all points on that line are not included in the solution. And if you have a less than or equal to or greater than or equal to symbol, it means that it's a solid line and all the points on that line are included in the solution set. Step 3 is to choose a test point in either half plane. You're going to substitute this test point into the original equation, and if it makes the inequality true, then you know that all those points where the test plane is located are true. If it doesn't make the inequality true, then the solutions lie in the other half plane. And you're going to shade that area which makes the inequality true. So here's our test point. We use 0, 0, and normally we always use 0, 0 unless the line's going through the origin. As you can see, once we substitute 0, 0 for x and y, we get 0 is greater than 6. Well, that's a false statement, or it's not true. So the solution doesn't lie where the test point's false, it only lies where it's true. So we shade the area that makes the inequality true. And it's a dashed line because we have a greater than symbol. Just make sure when you're picking a test point, 0, 0 is always probably used because it's the easiest one. But if you want to choose something else, make sure you don't choose a point on the line. It won't give you the results you're looking for. All right, example 1. Y is less than or equal to 1/2 x minus 3. All right, so the slope in this case, this is in slope-intercept form, so you should be able to identify the slope, 1/2, and the y-intercept, I'm just going to abbreviate INT, y-intercept is equal to -3. So the first step now is to plot the points. So -3 is actually 0, -3. Remember, y-intercept is when x is 0, so it crosses the y-axis at -3. Now we can find more points on this line by using the slope. The slope is always y, the change in y over the change in x. So we have y is 1, which is positive, so we're going to go up 1 and then over +2. You only need 2 points, but I'm going to do it one more just to show that you can go up 1 and over 2. Okay, so we've plotted the points. Now we just have to decide whether it's a dashed line or a solid line. In this case, it's a solid line, and I'm going to suggest that you guys use a ruler when you draw these lines, and always, always, always go all the way to the end of each graph information. Okay, so that's our line. It's a solid line. Now we have to find which side of the graph are we going to shade in, which half plane is true. So we're going to plug in test point 0, 0. Now you get to choose each time what test point you want to use, but why not use the easiest test point? So here's our test point, 0, 0. It's right here. So we're going to plug in 0 less than or equal 1/2 times 0 negative minus 3. So is 0 less than or equal to negative 3? No. So that means wherever 0, 0 is false, and so we shade everything that makes it true. Okay, so that's the first example. We're done with this one. The shaded area again is what makes this linear inequality true. Okay, example 2, y greater than negative 3 fixed x plus 4. Again, it's in y equals mx plus b form, so we're going to identify the slope, which is negative 3/5. We can, and the y-intercept is 4. Now we can plot the y-intercept is 4. Crosses the y-axis at 4. Now we have the slope. We can call this negative 3 over 5. We can call this positive 3 over negative 5. I always like to make the y negative. You also have to look and see where you're at on the slope, the coordinate plane. But I'm going to go down 3 and over positive 5. Okay, so I have my 2 points that I need. So we have to identify, is it a dashed line or a solid? In this case, it's a dashed line. So you just got to make some dashes. Make sure you're using a ruler. You get the arrows on the end. Last step is use the test point. I'm going to use test point 0, 0. So is 0 greater than negative 3/5 times 0 plus 4, 0 greater than 4? No. Again, here's our test point. This is no, so we're going to shade the opposite half plane. You don't have to color it all the way in, but just make sure that we can see what you're talking about. All right, example 3. I'm going to leave you this one to try on your own. Turn off the video and attempt it, and then when you come back, you can check your answer of what I've done. Okay, I hope you take a look at example 3 and you got it correct. Okay, let's go ahead now and take a look at example 4. Example 4 is not in y equals mx plus b form, but example 4 is in standard form. So what I'd like to do is create an XY chart. If you're uncomfortable with an XY chart, you can also go ahead and use, you can put it in slope-intercept form if that's easier. But what I like to do is take a look at, I like to make let x and y 0. So if x is 0, so 2 times 0 is 0, then we have, what we have to do is we take the number on the right side divided by the negative 4. So 16 divided by negative 4 is negative 4 when x is 0. Now, when y is 0, it means y goes away. We have 2x is less than 16, so we take the 16, divide it by 2, and we get 8. Now sometimes when you do these problems, the number won't be on the graph, so you're going to have to try a different number. So you want to make y a positive number. So what you have to do is we're going to make y a negative 2. So when we make y a negative 2, this is what it looks like. 2x minus 4 times negative 2 is less than 16, 2x plus 8 less than 16. We're going to subtract 8. 2x is less than 8, x is less than 4. I know you're supposed to put an equal sign, but I just like leaving it the same. So when y is negative 2, x is 4. So 0, negative 4 is down below. See, 8, 0 is off the chart. This only goes up to 6. So you may have to find a different point that's for x that's smaller. So we have 4, negative 2. Now that we have 2 points that are on this Cartesian coordinate system, we have a less than symbol, so it's going to be a dashed line. Again, use a ruler so you can make a better line. Okay, so now we're going to use a test point. I'm going to use the test point 0, 0. Plug it in, so I got 2 times 0 minus 4 times 0. Is that less than 16? Well, is 0 less than 16? Yes. So because 0, 0 right here is included, we shade this whole side. If you have to shade everything, just make sure you show which way you're going. Make it obvious that which side you're shading. Okay? Make sure you show it. Number 5, graph this inequality 3x plus 2y is greater than 12. Again, I'm going to use an xy chart. When it's in standard form, and if both the coefficients go into the constant on the right, we can again go 0, 0. If x is 0, that means the 3x goes away. We have y is 6. Remember, 12 divided by 2. That's the y value. The x value is, when y is 0, it means this goes away. 12 divided by 3 is 4. All right, let's go ahead and graph this. 0, 6, and then 4, 0. So we basically found the intercepts, the x and y intercepts for the inequality. All right, so it's a dashed line. We're going to use test point 0, 0. Is 0 plus 0 greater than 12? No. Zero is not greater than 12. So we're going to shade the 0, 0 is here, but we're going to shade the opposite way. These are the things that make the statement true. These are the solution sets on this half plane over here on the right. I'm going to give you example 6 to do yourself. There's x less than negative 3. So negative 3 is right here. It's a vertical line. It's a dashed line because it's less than. Okay, we just have to shade what's true. You can pick 0 for x. Is 0 less than negative 3? No. So you're going to shade this left side. Remember, x equals some number is a vertical line and y equals some number is a horizontal line. I'm going to leave you example 8 to do on your own, and if you have any questions, ask your teacher. Your essential question, make sure you're thinking about that while you're doing this work.